Welcome to a new Voltlog. In today's video we're going to be talking about castellated holes and how you can create them in your CAD tool. If this term is new to you, it's pretty simple to understand. You've certainly come across them if you've ever played with like a Bluetooth or Wi-Fi modules, because these 99% of the time will use castellated holes. Castellated holes are these semi-plated holes on the edges of a PCB. We can observe these on this ESP32 module, and having these connection points on the side of the module allows you to solder these modules on top of a main PCB which contains our main circuit. And I can also show you an example of a board I built which has one of these modules soldered on the PCB. You might ask yourself, why do we use castellated holes? Why not use a simple through-hole header as a board interconnect, or just some simple SMD pads? Well, in my opinion, the most important reason is the relatively low difficulty for soldering castellated holes. If you think about it, having some SMD pads that go, for example, on the bottom of the module, which is covered by the module, would make it pretty hard to solder, at least without proper equipment. You would need to have perfect alignment of the module on top of those pads which reside on the main PCB. Also, debugging such a module which would have the pads under the module is going to be a pain, because you won't have access to all of those signals to be able to probe them after the module has been installed. So this is where castellated holes improve. By having the half-plated holes on the side, you can solder them even with a simple soldering iron. Alignment is pretty easy because you can look at the module from the top and you can see if the pads align with the castellated holes, and you can go in there and touch these pads with the soldering iron and some solder, and you can get each one of these with a perfect solder joint. And debugging is much easier with this type of construction, because once again you can easily access these from the exterior, so you can do some measurements with your scope probes or a multimeter, whatever instrument you are using. So for the purpose of this video, to better exemplify a castellated hole design, I have designed and ordered a set of PCBs with castellated holes. These were manufactured by PCBWay, which are sponsoring this video. So let's open these up and take a closer look while I explain some more advantages and reasons for using castellated holes in your design. Another advantage of having castellated holes on a design is to think of it like a building block. So you might improve this building block externally, or switch to a new building block that uses the same pinout, and you then just drop this into your existing system as a simple upgrade. And believe it or not, but having a module with castellated holes can lower your BOM cost in some cases, because let's say you need some RF module which might be 4 layers, or a complicated system on module that may be 6 or 8 layers PCB with a powerful processor. So instead of building your entire main board and system on an 8-layer PCB and assembling that complicated BGA chip yourself, you can buy the module ready-made with castellated holes, and you just drop that module into your system, which might be just a simple 2-layer mainboard or 4-layer mainboard that will cost way less than the technology used to build that small module on 8-layer PCB. And if you are wondering how I designed these PCBs in Kicad, there will be a link in the description to a zip archive that you can download and check it out. But it's very simple, and you can apply this technique with pretty much any CAD software you're using. All you have to do is to use through-hole pads and run the board outline through the middle of those. In my case, the board outline layer is yellow, and it's visible how the yellow line runs through the middle of the plated holes which I placed. In production, the manufacturer, which in my case was PCBWay, puts the board through their manufacturing lines. They create those plated through holes just as they would do with every other plated through hole. But then when it's time to route the board outline, they run the router through the line you indicated as board outline, thus cutting through half of the plated hole, leaving you with these beautiful castellated holes. There are of course details to this process which are specific to each manufacturer, because for example to mill through all of these copper plated holes they probably need to use a different type of mill end that spins at a higher speed, and it's harder to prevent any sharp edges left behind, but basically that is the process. When ordering such boards, let your manufacturer know that your design includes castellated holes by ticking the corresponding box on the ordering page, because they will likely inspect and deburr your board differently if they know there are castellated holes present, but this ensures a perfectly looking board in the end, just like these ones came out. Sure, this will add some extra costs to your board, which is to be expected if the board needs special attention and handling, but not ticking that box means your board will go through the regular process, which will almost certainly leave you with some sharp burrs from running a standard mill through the plated holes, and no one will deburr your board through the standard process, and as well it might cause problems in their manufacturing process, because if they use like a standard end mill to go through your board because you didn't specify it as castellated holes, the mill end might break. So I'm not sure if they will allow that if you do not tick the required box. Here are some images I took under magnification of these boards. As you can see, the gold finish is perfect. There are no burrs left behind, not even on these bottom holes, which are pretty small 0.6 millimeter holes and tightly packed together, and I think 0.6 millimeter is the minimum recommended drill hole size that PCBWay will manufacture with castellated holes. Anything smaller than that just leaves too little copper for it to be stably attached throughout the manufacturing process. So I hope this video was useful and you learned something interesting, because knowing how to implement castellated holes in your project can be a useful skill to have in your toolkit and might help you benefit from the advantages that this technique presents. Don't be afraid to order your next PCBs with castellated holes, as long as you go with a reputable manufacturer like PCBWay and you correctly specify them, they will come out perfect, just like I shown here. I would appreciate your feedback in the comments. Let me know if you have any experience with castellated holes, if they helped you in your past projects, or maybe if you plan to use them in a future project now that you know more. Thank you for watching, and I will see you next time with a new video.